Hello, we are the SpaceGoats from WPI. Our mission is designing a robust robot to scout and navigate the unpredictable lunar terrain. We determined that the robot needed to be flexible and adaptable to support dynamic movement and carry substantial payload weight.
We have created a quadruped robot with S-shaped limbs to meet our objectives. It is anticipated to effortlessly climb steep inclines, dig itself out of a hole, and hop on top of or over tall rocky structures. The ingenuity behind the SpaceGoat design is in the non-fluidic one-to-many transmission using the capstan mechanism as clutching devices.
In our OTM system, the prime mover is rotating all the shafts at the same speed, while the small control motors facilitate the engaging and disengaging of the capstans, thus controlling each output degree of freedom separately. Basically, the prime mover provides the motor power for all degrees of freedom, and the small control motors distribute that power in a highly controllable manner. As a result, the OTM system allows for greater control and ease of robot maneuvering that a normal gear transmission would not. Furthermore, it has the added benefit of reducing the robot's overall mass by needing only one massive central motor instead of one for each degree of freedom, which results in a great power to mass ratio.
This is a demonstration of our differential capability. We can run each of the legs at different speeds. Starting from the bottom left leg and going clockwise, the legs are running at 0, 40, 80, and 120 RPM.
We have developed a prototype named V0, which demonstrates proof of concept for the OTM system and novel capstan actuator, as this is the first time both are being used in a functioning robot.
The robot's legs can be engaged simultaneously and separately, which allows us to modify its gait. As a result, we can easily customize the speed of the robot, trotting to galloping, and/or the orientation of its body. In the second gait, the body of the robot stays relatively stable, unlike the first where it was bouncing up and down off the ground.
We've created simulations of the robot behavior under given weight, gravity, and friction constraints. As shown, the robot can overcome tall obstacles and climb steep inclines.
We are currently developing an updated version of the robot. At this time, we are optimizing the capstans and comparing coil and rope to determine the best capstan material and design. We are also expanding on the capstan design to introduce bidirectional control. In addition, we have begun exploring a power augmentation unit based on the capstan technology, which will store and instantaneously release energy, as well as a method to control leg stiffness and shape, which would aid in jumping. If we have time, our stretch goals include adding a degree of freedom in the yaw direction for each leg.
I'm honored to be advisor of this enthusiastic, ingenious team. The robot they're building will likely have a profound effect on the future of space robotics. Thanks me and NASA for organizing this.